Welcome to CH225 course on Statistical Data Analysis for Chemists. This is video 38 in this series. In this video, we will continue to learn about simple linear regression. One of the important aspects of the regression analysis is to establish that there is a relationship between variables x and y. This can be achieved using hypothesis testing. Here, we keep our null hypothesis as beta equals to 0. This means we start with the assumption that there is no relationship between x and y. Beta cap is the estimator of beta, therefore we need to study the distribution of beta cap. The expected value of beta cap is beta. We know that the variance of y is sigma square. Therefore, the variance of beta cap is sigma square divided by SXX. Once we know the expected value and the variance of beta cap, we can write the equivalent standard normal distribution as shown here. We also know that sum of the square of the residuals divided by n-2 is an estimator of sigma square. Therefore, this will have t-distribution with n-2 degrees of freedom. Therefore, the test statistic for our null hypothesis will be as shown here. It will be a t-distribution with n-2 degrees of freedom. Now, we can easily carry out the hypothesis testing for a given significance level using sample data and take the appropriate decision about the null hypothesis. Once we know the distribution, we can easily find out the confidence interval of beta as shown here. In the similar fashion, we can also find out the upper and the lower bounds, or the so-called one-sided tests, of beta. Let us now learn another important concept called regression to the mean. This concept was originally developed by Francois Galton to describe the laws of inheritance. Galton believed that these laws caused population extremes to regress toward the mean. By this, he meant that children of individuals having extreme values of a certain characteristic would tend to have less extreme values of this characteristic than their parent. If we assume a linear regression relationship between the characteristic of the offspring, variable y, and that of the parent, variable x, a regression to the mean will occur when the regression parameter, beta, is between 0 and 1. Regression towards mean happens when the expected value of y is smaller than x, when x is large, and greater than x, when x is small. This is the pictorial representation of the same. In order to prove regression towards mean, we assume our null hypothesis to be that the beta is more than or equal to 1. Our alternate hypothesis will be that it is less than 1. I am sure you all know why we did not consider the null hypothesis to be that beta is less than 1. Remember, accepting a null hypothesis is not as strong a statement as rejecting the null hypothesis. Since this is an important hypothesis, we assume beta to be more than or equal to 1 and reject the null hypothesis using sample data to gain more confidence. Now, our test statistic will be t-distribution with n-2 degrees of freedom, as shown here. It is simple for us to now calculate the p-value using the sample data and decide about the null hypothesis.